Hello, and welcome to another in our webinar series at CISA. This webinar is highlighting a new report that is out assessing the value of energy storage, a framework for states. I will be doing a little brief introduction, and then I'll be turning the remainder of the time over to our presenters. We will take your questions in written form. You can type those in. There's a questions panel that you should see on your screen, and just go ahead and type those in as they occur to you. At the end of the presentation, we will plan to have some time for addressing those questions and any comments or discussion. We won't be interrupting the presentation for that, but we will address as many as we can at the end. Let me do a little introduction here. I'm Todd Olinsky-Paul. I'm a Senior Project Director with Clean Energy States Alliance, or CISA. CISA is a nonprofit. We're located in Vermont, and we work with energy agencies in states all over the country. You can see many of the members' logos on the screen here. Essentially, CISA is a membership organization for state energy agencies. And what we do is we help them to improve their programs and policy, whatever it is that they're working on that they need help with. We do research, we help with collaborative information sharing between states, we help them to put together proposals for funding, and we do all kinds of other things. So that's CISA, and if you could advance the slide, please. So we, of course, in addition to working with states, we work with many other organizations. In this case, we have worked with the Applied Economics Clinic, and I'll let them introduce themselves in a moment. But we've done many reports and analyses with Applied Economics Clinic over the years, many of which have focused on the Northeast, but in this case, we are really focusing on a broad sort of framework for states in conducting energy storage benefit cost analysis. And so this should be of use to all state energy agencies. It really sets up a sort of a broad framework for this analysis, and I'm going to explain a little bit about why that's important, and then I'll pass it over to Liz and Brindis from AEC. So benefit cost analysis, and some people call it cost benefit analysis, same thing. It's very simply, in its sort of most simplified form, it's just comparing the costs of a thing with its benefits and seeing which one's greater. And obviously that's important because nobody wants to pay more for something than it's worth. So no matter what it is, whether it's solar panels or a car or a house or in this case battery storage, you want to make sure that the benefits that you're getting from whatever it is that you're purchasing are going, or in this case at the state level, whatever it is you're incentivizing, are going to be worthwhile. And if they're not worthwhile, then you may want to consider whether it makes sense to spend public money on such a thing. So the question then is how do you conduct this analysis in a way that is equitable and fair and takes into account all of the costs and also all of the benefits? And where it gets tricky is when you have a new technology, relatively new, like energy storage, where states may not be very familiar with how to value the benefits and also how to conduct other aspects of a benefit cost analysis so that the results are going to be fair and reasonable and reliable. So that's what this is about. And I will say that energy storage is a little different from some other clean energy technologies like solar, which we might be more familiar with, for the simple reason that it's a multi-use resource. And what I mean by that is that something like solar, basically it does one thing. It generates electricity when the sun is shining. If the sun isn't shining, it doesn't. And it's pretty simple to, therefore, to look at that and say, well, what are the benefits of this? Okay, well, there's the energy it generates, but there are other benefits. If we can retire fossil fuel generation because we've installed solar, that may provide some benefits. But we pretty much know what the solar is going to do. With storage, it can get a little more complicated because batteries are dispatchable. You can use them in many different ways. You can turn them off and on. They sometimes behave kind of like generation, but they sometimes behave kind of like load or demand. And so it's not enough to simply say we're going to have storage. You also have to look at what's going to be done with it. Are we going to use it to reduce fossil fuel emissions, related emissions? Are we going to use it as a non-wires alternative, so we don't have to invest in more transmission, distribution, and substation infrastructure? Or are we going to use it for resiliency, so that if the grid goes down, we can still have power to critical infrastructure? So there's all these different things you can do. And depending on how you structure your incentive program, for example, if we're talking about a state incentive program, you might incentivize some uses for storage and you might not incentivize others, or you might incentivize a whole broad range of uses for energy storage. And then you need to have a broad range of values attached to those different uses. And you need to look at how those values compare with the costs and under different kinds of programs and scenarios. So that's all I'm going to say. I'm probably making this sound more complicated than it is, but I'm going to pass the microphone over to our two presenters from Applied Economics Clinic, Bryndise Woods and Liz Stanton, and they will demystify what I've just said, hopefully, and present it in a way that makes a lot more sense. And then we'll come back and we'll address your questions and discussion points. So that's it for me. Over to you, Liz and Bryndise.
Thanks, Todd. Thanks so much. That was a really helpful introduction. I'm Liz Stanton. I'm the Director and Senior Economist at the Applied Economics Clinic. I have with me Bryndise Woods, who is the lead author of this report and is a senior researcher at the Applied Economics Clinic. And we're a nonprofit consulting group. And we are based in Massachusetts. We're mission-based. We're working to provide low-cost expert services to public interest groups, as well as train up a new generation of experts and work to diversify our field. For this report, we were setting out to better understand and lay out instructions for how to conduct a benefit cost analysis on battery storage. I'll talk for just a moment about our methods, and then Bryndise will pick it up from there and talk through the components of benefit cost analysis, cost effectiveness tests, discount rates, benefits, costs, sensitivity analysis, and the stakeholder process. And then we'll wrap it up with some recommendations regarding cost-benefit analysis and battery storage. So to begin this with a little bit on our methods, we reviewed 29 different battery storage benefit cost analyses that have already been conducted in the United States to try to look for best practices, find out what's been done in the past, find out what's recommended and not recommended. Those studies came from utilities, from utility commissions, from state energy agencies, green banks, and also from research groups. So for each source that we looked at, we were looking at a number of different things. And part of that was the benefits. What are the different benefits that are associated with battery storage? What are the different costs associated with battery storage? And then for each benefit and each cost, what is a good way to get at a value for that benefit or cost? But in addition to that, we looked at some methodological elements of a benefit cost analysis, including what kinds of cost effectiveness tests are utilized, what are the discount rates that are used within the study, what kind of sensitivity analyses are used to test the robustness of results to changes in assumptions. And then we also looked into what kind of stakeholder engagement there was around the cost-benefit analysis, developing its assumptions, and reviewing its results. Finally, our recommendations that we present at the end of the report and towards the end of this presentation cover 6 areas: cost effectiveness tests, discount rates, benefits to measure, costs to measure, sensitivity analyses to perform, and some recommendations around that stakeholder process. So I'm going to turn it over to Brendice to walk you through each area.
Thank you. So I'm going to go through each of these 6 components that we reviewed for battery storage cost-benefit analyses. And the first is cost-effectiveness tests. So this table might be a little hard to actually read, but I'm going to just talk through it really quickly. And of course, you can find it in the report that is on both our website and on CESA's website. So the first area that we looked at was cost effectiveness tests. And so we reviewed those 29 sources and took a look at what cost effectiveness tests they were utilizing. And we found that there were 6 that were primarily getting utilized. Those included societal cost tests, total resource cost tests, participant cost tests, utility cost tests, program administrator cost tests, and ratepayer impact measures. And so this table and the text that's around this table in the report gives a flavor of sort of what are the typical benefits that are included and costs that are included for different studies that use these different kinds of cost tests. But the ultimate distinction between these different cost tests, of course, is sort of the vantage point from which they're being conducted, right? So a societal cost test is taking, the vantage point of society as a whole versus a utility cost test, which is taking the vantage point of the utility. And so our recommendation in this space for a battery storage benefit cost analysis specifically is to use the societal cost test as the primary cost effectiveness test, and then the utility cost test and ratepayer impact measure as secondary tests. And this recommendation is consistent with the approaches employed in several other similar BCAs that we reviewed, including some from the Connecticut Green Bank and the New York State, and a couple of others that were comparable to the type of battery storage benefit cost analysis that we were reviewing here. The second component that we looked at were discount rates. And again, this table might be a little difficult to actually read, and you can find it in the report, and I'll just present it at a high level here. But basically, there are 2 categories of discount rates that are at issue in a battery storage BCA. The first are social discount rates, and the second are financial discount rates. And so what social discount rates, sometimes called social cost of carbon, what those are trying to do are take future costs and benefits and translate those into current costs and benefits. And so those in our review ranged from a low of below 1% to a high of 3 to 5%. And ultimately, the lower the social discount rate is, the more that future costs and benefits are assigned a value that is similar in importance to current costs and benefits. And then financial discount rates are sometimes called the weighted average cost of capital, or WACC. Those represent the rate of return on an investment. So the idea is a firm's own weighted cost of average cost of capital is the rate that it needs to pay its investors or lenders, so the minimum rate of return that needs to be recouped on any particular investment. And in our review, those ranged from around 7% to around 10%, but these are in general pretty specific to the firm that we're talking about, and are going to vary from one entity to another. And so our recommendation in this space is to use a 0.1 to 2.5% social discount rate, and then to use each utility's own weighted cost of capital as a financial discount rate. And there's a caveat here, which I will get to when we get to the sensitivity analysis portion, which is that discount rates need to be chosen really, really carefully in a battery storage BCA, because, and they need to be context specific, because really small changes in discount rate assumptions can have big impacts on final model results and on BCA calculations. And I'll go into a little more detail on that when we get to the sensitivity analysis portion. So the next category that we looked at was benefits, and this is really the meat of our report. This is the bulk of the pages in the report are dedicated to this component, to benefits. And the reason for that is because in our review of these types of analyses, in general, they do a very good job capturing the costs. The costs are pretty straightforward and pretty well reflected in every BCA that we reviewed. The place where there are improvements to be made are in the consideration of the benefits of battery storage. And what I mean by that is that obviously the fewer benefits that you consider and include in a benefit cost analysis, the worse off battery storage is going to perform in terms of a benefit cost analysis. And so sometimes it was a matter of, these benefits just weren't being fully considered, certain benefits were being left out. Sometimes it was a matter of, a study would say, okay, we acknowledge this benefit exists, but we don't have enough literature on it or enough research on it to assign it a value, so we're not going to include it in our analysis. And when a benefit is treated that way in a benefit cost analysis, which is to say we acknowledge this benefit exists, but we're not going to assign it a value, that is the same as assigning it a value of 0. So when you do a battery storage benefit cost analysis, it is important to utilize as best you can as the sort of new and novel estimation techniques that exist out there, or to create a range of values for benefits that are difficult to capture. And so I'm not going to go through each of these benefits in detail, but what we found is that there are 5 broad categories of benefits and 25 benefits total. So our recommendation in this space is that any battery BCA needs to include all 25 of these benefits and assign them a value. And so the first category are consumer benefits, which are exactly what they sound like, the benefits that are conferred to the battery storage program participants or electric ratepayers more broadly because of battery storage programs. And those are things like lower ratepayer bills, lower customer energy use, fewer power outages, new jobs are created, property values are enhanced, or enhancing the value of and capacity of existing renewables or new renewables on the system. The second category of benefits are avoided system costs, which are the reduced costs experienced by utility customers or the electric system overall because of the implementation of battery storage programs and battery storage resources. So those are things like avoided operations and maintenance costs, avoided costs of environmental compliance for the utility, avoided capacity and fuel costs for the utility as well, avoided transmission and distribution costs, a lot of avoided costs, right, from adding battery storage onto the system. Then the third category of benefits are environmental benefits, which are exactly what they sound like, benefits to the natural environment and to the human communities in those natural environments from integrating battery storage onto the system. So battery storage has a smaller land footprint than traditional generation facilities. They can help reduce greenhouse gas emissions and local hazardous air pollution, reduced water consumption, things like that. The fourth category of benefits are grid reliability benefits. So battery storage, because of the way that battery storage works, can enhance the overall grid's reliability and offer benefits related to enhanced reliability to customers, to utilities, and to the electric system itself. And so those are things like fewer power outages, avoided emergency calls, shaving peak electric demand and shifting peak demand, black start capability, and reduced grid congestion. And then finally, and these are the ones that most often get kind of named and not valued, are these difficult to monetize benefits. So these are the ones that most often we would see, you know, a source that we would review say, okay, well, this benefit exists, but there's not enough information out there, or it's really hard to quantify, so we're just not going to. And those are these what are called non-energy benefits. So benefits to participants or society that don't have to do with energy per se. Things like, you know, enhanced public health or environmental justice kind of benefits. But again, these are really important to include in a battery storage BCA and to use as much information as you can gather and you know, start to employ new and novel techniques to quantify these things and include. The next category that we looked at were costs. And as I mentioned, these are pretty well, you know, covered in the sources that we reviewed. There are three main sort of buckets of costs that are included in a battery storage BCA. Those include program administration costs, so the cost of offering customer incentives and rebates, the cost to acquire the necessary permits and licenses, interconnection agreement costs, things like that. The second bucket is capital and labor costs, so literally the cost of labor and equipment and the infrastructure necessary to integrate battery storage resources and to regulate them and to monitor them. And the final category of costs are program operation costs, so fixed and variable maintenance costs, round trip efficiency losses, warranty fees, insurance fees, things like that. And so our recommendation in this space is simply to capture these costs and to make sure that you're utilizing as up-to-date as possible battery-specific references to establish the most up-to-date and correct program costs that you can. And in the report, we include, in this report section, we include a couple of really helpful resources in this space. Resources that provide a description of these various costs and places where you can find up-to-date information about them. Then the next component that we looked at were sensitivity analysis. And as I referred to earlier when I was talking through discount rates, it's really important that you test the sensitivity of your battery storage BCA in a couple of different ways. So our recommendation is that a battery-related BCA needs to conduct more than one sensitivity analysis for two main purposes. And the first is to calibrate the model, and the second is to test, is to apply a sensitivity analysis to the full model results. So let me talk through what I mean by that a little bit. The first way to utilize sensitivity analysis is to fine-tune the model itself, to calibrate the model. And what you're doing here is you're trying to ensure that small changes to your input assumptions don't have large changes in the model results. So for example, it would be a bad sign if a small change in a fuel price assumption led to finding a benefit cost ratio, led to your benefit cost ratio going from being positive to negative, for example. That indicates that your model is overly sensitive to this particular input assumption. And so using sensitivity analyses in this way can help you to fine tune and just calibrate and make sure your model isn't drastically changing its outputs based on small changes in input assumptions. So the types of things that you would want to include here are fuel prices, as I said in the example, also capacity prices, power prices, resource adequacy event notifications, frequency regulation, battery efficiency, renewable penetration, all those kinds of assumptions. You want to utilize sensitivity analysis to make sure that your model is doing what you want it to do and isn't overly sensitive to any one of those input assumptions, making small changes to it. The other way that sensitivity analysis should be used is on the full model results. So here, the idea is to capture the uncertainty that it is inherent to certain assumptions to provide a range of values as a result instead of a single value as the result. And so what we're doing here is basically reflecting the uncertainty inherent in the discount rates that we mentioned before. So you want to make sure that you're presenting including a range of social cost of carbon discount rates, so the less than 1%, to the 2.5%, and then a range of financial discount rates as well. And so this is a sensitivity analysis that's being applied to the full model results. And we recommend that both of these be done in any battery storage BCA. The final category we looked at was stakeholder processes. And this one was definitely the most variable in terms of the amount of information that the sources we reviewed included. Sometimes the sources made no mention of whether a stakeholder process was conducted. Sometimes they said, okay, we conducted a stakeholder process and that was about all the information they provided. Sometimes they were, more specific in saying, the number of meetings and when they took place and who participated in these meetings. So that's a sort of lesson too when battery storage BCAs are being conducted, to make sure that, in whatever output is being generated, a report or whatever it is, that, making sure you mention that a stakeholder process happened or didn't, and give some information about what it included. But stakeholder processes are really, really important. And so we recommend that they always happen and that they happen in parallel with the entire BCA process. So from the very beginning all the way to the very end. And they're important for a bunch of reasons, but one of the foremost is that, if you're doing a battery storage benefit cost analysis, hopefully you're trying, and you find that battery storage is cost effective. The idea is that you're going to deploy battery storage. You're going to launch a battery storage program. You're going to do something to develop battery storage resources. And you want buy-in from the communities that this is going to impact. And that's really what a stakeholder process can help you achieve. It can help you get the buy-in from the folks that you're going to need on board to help, execute a program and make sure it is beneficial in the ways that everyone is hoping it will be. And stakeholders can also help with the actual BCA. They can help identify important information and data. They can help identify key market drivers, important barriers to deployment that need to be considered. They can help develop appropriate peak load forecasts, identify costs and benefits that are context specific, recommendations for program performance metrics and reporting requirements. They can help you select appropriate discount rates. They can provide just additional information and materials related to the analysis or important context that individual regulatory agencies or individual utilities might not have. It's just a sort of, the more minds and perspectives that you take on an issue, the more robust a BCA is going to be. And so we recommend that a stakeholder process happen, that it be inclusive, diverse, and equitable, that it be parallel to the BCA process, and include representatives from a bunch of different with a bunch of different perspectives. So you want folks from state agencies, from utilities, you want consumer and environmental advocates, someone to represent low-income consumers and ratepayers specifically, Make sure you have, regulators involved, environmental justice communities, NGOs, government organizations, renewable energy developers, and how about some battery companies too, right? Like you want to make sure you're getting all of the different viewpoints on battery storage that are going to help ensure that the BCA you're conducting is as robust as possible and has the buy-in that you really need for success. So those are the categories that we reviewed, and this summary table is by way of a conclusion to say that we looked at almost 30 different resources to assess how they approach these various categories of a battery storage BCA, and we summarize what they've done in the report, and we also make recommendations about how for best practices for battery storage BCAs across these various categories, which again are the cost effectiveness tests, discount rates, benefits, costs, sensitivity analysis, and stakeholder process. And this summary table, you can find it, I think it's at the very tippy top of our report, and just summarizes everything that we've presented here today in terms of our recommendations. So I'm glad to say I'm a little ahead of time. I wanted to leave plenty of time for questions and answers, and I can move to the next slide where we've got contact information for myself, Brindis, Liz, who's also here with me, and some links showing you where you can find the report. So thank you, and happy to answer questions.
Great, thank you so much for this presentation. We have a lot of questions, so people are clearly paying attention, and I'm glad that we're going to have plenty of time to get to these. Can we go back to the slide, the kind of summary table, just so we can have that in front of us when we're addressing some of these questions? Great.
Are you all seeing that now?
Yes, thank you.
Okay, great.
Great. So one thing I want to do before we get to questions from the audience, just go for a second back to the discount rate, because I think that's one that, I mean, most people understand what a benefit is, what a cost is. The discount rate is a little wonky, and I just wonder if you could give an example, even if it's just sort of off the top of your head. What difference does it make? In other words, I've seen benefit cost analyses that use a 2% discount rate, and I've seen ones that use a 15% discount rate, and that can make an enormous difference. Can you just explain like what the real impact of that is when you're looking at a cost versus a benefit for something, and you use that kind of that wide a difference between discount rates?
Liz, do you want to take that one at first?
Sure, you bet. So it makes a lot of difference. The amount of difference that it makes depends on the length of the analysis, how far you're looking into the future. So the further you're looking into the future, the more that the discount rate matters. If you're doing an analysis that's just covering the next couple years or even 5 years, much less so. If you're doing an analysis that covers 50 years, then the discount rate can become really a dominating factor in what kind of results that you're getting. Now, the spread of 2% to 15% is a really big spread that you were describing, Todd. Usually, there's a pretty clear distinction between what we're calling a social discount rate and a financial discount rate, and they're used for a little bit different purposes. For a social discount rate, even 5 years ago, I would have said that those are all going to be under 7%. 3 to 7% used to be kind of a standard. It's all moved down a little bit. So now you usually see social discount rates that are between 0.1 and 3% as a social discount rate. It's still a really big range that makes a lot of difference. It's the financial discount rates, those weighted average cost of capitals you see, that are much higher. And those are usually decided on and approved in utility commission processes, where in a rate case or what have you, there'll be testimony and argument regarding what is the appropriate weighted cost of capital to use for a particular utility, and they get determined in that way. And what you want to see is for that higher discount rate to be applied to things that are really financial instruments. It's really something that can be bought and sold in a marketplace. And that discount rate, whether it's 10% or what have you, it has been created based on some kind of real world process of what is an actual return that folks are getting, and from that, how does that change values over time? The social discount rate is really different than that. The social discount rate isn't about financial instruments, and it isn't about things that can be bought and sold in the market. It's about how we feel about costs and benefits that occur in the future. So it's much more subjective, but it's a real and important thing that we know with climate change and with some other long-lasting environmental impacts, that the impacts of our actions are going to occur not only today and not only in the next decade, but well out into the future. And so we want to be able to take that into consideration in our own way and to ask the question, what is that worth to us? If there's going to be a cost or a benefit in 2050 or in 2100, what is that worth to us today? What does it mean to us today? And so the smaller discount rates, the 0.1 to 3%, that's about expressing how we feel about it, how we want to consider it in comparison to costs that happen today, much more subjective.
Great, thank you. So let's go to audience questions. One person wants to know, how does this modeling take into account the battery recycling process? And that brings up a bigger question, which is, what is this looking at? Are we in doing benefit cost analyses, are we looking at the entire life cycle? And so we're taking into account production, manufacturing, all the way through to decommissioning, recycling, or disposal? Or are we looking at just a piece of that? In other words, from when we, for example, install a battery to when its end of its useful life is reached? Or are we really looking at something else entirely, which would be like a state program to incentivize the installation of batteries, in which case maybe we're looking at the lifespan of a program, not of a technology. So can you just clarify what this takes into account, or what it should take into account?
Liz, do you want to start that one off, or I'm happy to as well?
Typically what you're going to see in any kind of utility cost benefit analysis, or ones that are associated with utility activities, are not life cycle. That would be unusual. I'm not saying it's bad, and I'm not advocating that it's not included. I'm saying what's typically there. It's not life cycle. It's about the impacts that are the end of the line impacts, the direct impacts in that moment, not going up through a value and supply chain to impacts that came before. So that means that you typically won't see included, for example, if you're talking about gas use, you won't see leaks, methane leaks associated with a transmission system, right? That's upstream, or associated with refining gas. But that's upstream, and that's not going to appear here. And so with batteries, you're unlikely to see here estimates of the impacts of developing those materials to build batteries, and the waste products associated with them aren't here. And in that, and in our recommendations here, we are following sort of the typical practice by utility commissions of making these decisions, is not including those upstreams. I think there's a lot of space to include that. You get into a lot of measurement issues. You get into, if we're going to include that, how will we include it? What's the appropriate way to do it? I think that the place that we'll see this first, and the change to how these decisions are made, is with the first example that I gave of thinking about upstream impacts of fuels in our utility systems. I think we're a lot closer to considering those things. But here, with the recommendations that we're putting forth, we're just looking at the end. We're not looking at upstream.
Okay, great, thank you. Somebody wants to know, well, I'll just read the question. While societal costs are real, how are these benefits incorporated since utilities and other installers do not pay these costs? It's a little confusing the way the question is worded, but I think the question is about how since there are I think what they mean is societal benefits. Since societal benefits aren't being directly paid for by utilities or installers, how do you incorporate those into the cost benefit analysis?
Did you want me to take that, Brandeis?
Sure, I'm still not sure I understand the question, but if you do, please.
I think I do. So that's really a question about the cost effectiveness test and the different styles of cost effectiveness tests that are used in utility decision making are meant to address exactly that question. And the way that Brandeis expressed it earlier was as a point of view. So from whose point of view are we talking about costs and benefits? And different cost effectiveness tests take different points of view. The societal cost effectiveness test takes the point of view of what are the costs and benefits to society at large, not just a utility company, not just utility customers, not just owners of batteries, but rather society at large. There's a couple other tests, one that looks at things from the point of view of the utility, one that looks at things from the point of view of the ratepayer, but each of those tests takes on that idea and tries to figure it out and say, which kind of cost or benefit should we include in this test because we're coming from the point of view of a particular entity.
Okay. I guess part of what I think the question is getting at is valuation and the relationship between valuation and monetization. So we say that we're going to have a societal benefit. So let's take just a different example. We say, okay, we're going to incentivize batteries to be installed with solar. And so there's a societal benefit, and that societal benefit is cleaner air, because when we get enough solar and storage installed, people will be using that more and buying grid power less, and the grid power is contributing to air pollution. So therefore, eventually we will have less air pollution. Okay, so that's a benefit. Everyone can agree, I think, that that's a benefit. We don't want to breathe in polluted. But who's paying? So how do you then get to monetize that benefit as somebody who is contributing? So I've invested in my solar and my battery, I'm maintaining them, I've created space in my house or business for them. You know, I'm paying interest on a loan so that now I have an additional cost for that, and I'm contributing to a societal benefit. How do I get paid? How do I get compensated? Are there mechanisms to link a benefit with some kind of monetization for the provider of that benefit?
Well, you're touching on a couple of different things there, Todd, that are really important and at the essence of cost benefit analysis and the good, interesting things about cost benefit analysis and also some of its limitations. It's always a challenge in cost benefit analysis when you have benefits, usually cost to, that are not monetizable, right? They're not something from the market. You could try to put a dollar value on them, but it's not going to be perfect and it's not going to quite make sense, right? Even if we're talking about clean air, right? If we're talking about a kind of environmental effect that affects communities or it affects human lives, people could be killed. How do we monetize those things? And indeed, should we monetize those things and to then compare them against things that really do cost dollars and cents in a marketplace, as if you could trade one for the other. You really can't. So you're getting into that area of it's something where there are real benefits here that are things that are important to society, but they shouldn't necessarily be reduced into dollars and then said, oh, well, I'll trade that against this dollar over here because nobody really operates that way. So that's one kind of issue with the whole space of cost benefit analyses. And there are some different styles of analysis that have been invented to try to deal with that. It's kind of a different topic. The other question that you had was about, okay, I'm creating a benefit. I'm doing this thing and creating a benefit. I'm creating a benefit for society. How do I get paid for that? And there have been tools and systems that have been invented to do just that. I have not heard of it in the space of batteries or solar panels or something like that, where you're trying to monetize specifically your greenhouse gas impact or your pollution reduction impact. I have seen things like that, for example, where you have a problem with pollution entering a water source that people rely on to get their clean water. If the water isn't clean, you'd have to pay billions of dollars to build a treatment system, right? So if you could stop that pollution, that's incredibly valuable. It's even valuable in dollars because you can avoid building that sewage treatment plant or that pollution treatment plant. And so there have been systems created to, for example, pay farmers upstream to not put certain kinds of fertilizers or pesticides on their crops, specifically to have that effect of cleaning up the water so that a water treatment plant didn't have to be built. It's a real clear monetization of that benefit stream. So I've seen it like that in a couple cases where it's really clear cut. If you do this, this happens. Therefore, we have a way to pay for this thing, right? And get some money to pass upstream. But I haven't seen it in this space. So it's an interesting idea that I think in order to get it to an eventual end point, there has to be a way to fund that, to say, okay, if we don't do this, then we'll have to pay money for this. So instead, we'll take the money and get people to put in batteries or whatever it is.
Right. And I think that this is a lot of what state energy agencies do. They, for example, an incentive program, we're going to say, well, we're going to provide a rebate for solar, for example. In Massachusetts, for example, there's a rebate for solar. And if you add battery storage, then you get an adder for that. You get an extra incentive, right? And that's just a way of saying, look, we recognize that markets haven't caught up with the technology in some cases. We have these technologies that provide a benefit. There's no easy way to get compensated for that, but we think that it's valuable. So we're going to provide an incentive to make up for the lack of a market where you could sell your air cleaning services into a market, for example.
Yeah.
Another example is an RPS, so Renewable Portfolio Standard, where the state would say, look, we think that renewables are good, they provide social benefits, so we're going to say to the utilities, you have to procure a certain percentage of the power from renewable resources, and if you don't, then you have to pay a fine. And that fine puts a price, essentially, on that service. So then the utility is going to go out and say, well, look, we'll purchase your solar power or your battery, services or your wind power, and we'll put that into our portfolio mix for what we sell to our customers. And that way, we don't have to pay these fines. And so in that way, there's a market created. So it's a good question. There's a lot being done at the state level, and this is why we have such successful programs like RPS programs and incentives.
I think that's a really good example, Todd, and it's within this space, but it's not specifically about the greenhouse gases, which is a little offset. And so there's the word that I was going for is offset. That's another area that's similar to this, is in the market that's being created for offsets and for carbon offsets. And so there's all sorts of problems in proving that the offsets are real, that they really happened, that they wouldn't have happened otherwise, right? To figure out a thing that can be bought and sold and you get a value for it. But that could be another space related here is the offset market.
Right, and that brings up another issue, related issue that you touched on, which is that often these are not easy questions to answer. But just because they're difficult doesn't mean that we should ignore them. And as you said, if you say, well, it's kind of hard to put a value on resilience, for example, this is a classic problem in battery storage that provides resilience. Studies have shown that the majority of residential customers who install a battery in their home do so because they are looking for a resilience benefit. They want to be able to have their lights on and their refrigerator running and so forth when the grid goes down. So they invest in a battery and solar often. And so what's the value of that? And it's very, sort of famously difficult to put an objective value that's a fair value and a complete value on resilience. And yet we know it's important. And so if you just ignore it when you're doing a benefit cost analysis, if the state or the utility or the regulatory agency says, well, we're not really sure how to value the service, so we're just going to set it aside, as you said, that defaults to zero in the analysis. So it's important that we try to value things, even if it's difficult, even if they're not monetizable in a market, because if we don't, we're leaving it out. And then if you leave it out, the benefits don't meet the costs, and then the whole proposition collapses, right? We can't then make the case that it's worth investing in these clean energy resources because we haven't made the effort to establish values for their benefits. I want to ask you a simpler question because somebody wants to know what the acronyms mean: SCT, UCT, RIM, et cetera. Can we go to wherever that slide was and just walk through that so that people understand? And these are tests that are used by states, and different states use different tests. And these are cost effectiveness tests, and they each test different things, and that's why it's kind of important to understand that. So if you could just walk through that a little bit.
Yeah, so I hope everyone's seeing the slide here where the acronyms are spelled out. All those acronyms that you just listed, Todd, were different types of cost tests. So SCT is the societal cost test, UCT is the utility cost test, and RIM is the ratepayer impact measure. And then there's a couple of others here as well, TRC, PCT. Always fun with acronyms. But yeah, these are all the various cost tests that are traditionally employed in benefit cost analyses of this type. And the reason that those three acronyms feature on the last slide there is because those are the ones we're recommending that battery storage BCAs in particular utilize.
It might be worth just sort of underlining the fact that these tests are not equivalent to each other. And right, I mean, they can be very different. So the test that is used, just the fact that the state is, or the utility is using one test rather than another, can really have a big impact on the outcome, right? So if I'm making this up, but if New York, for example, is using the societal cost test and Illinois is using the utility cost test, they're going to come up with very different results when they look at the same question, right? Is this technology or is this incentive program worth the investment?
Yeah, and this is kind of related to the last question too, which is, how do you monetize the costs and benefits that you want to include? So these tests determine which costs and benefits are included. And then the question of how to monetize is also going to be a little bit different depending on which perspective you're taking. So take reliability, for example. Do you mean from the utility's perspective, or do you mean from the customer's perspective? And those are two different answers to what is essentially the same question, right? What is the value of reliability. So the different cost tests that you're going to utilize will influence the way you answer the question, the perspective that you're using to answer the question. And this also, I just, from the conversation before, which was great, I think this also, these various cost tests and sort of the benefits that are included or not included in these various ones also speak to the kind of mushiness of the categories that we presented. Like, so we gave you a list of societal benefits and a list of environmental benefits, but one could easily argue that there's a lot of overlap between those things, right? Like, we can say that reduced air pollution is a benefit to society, and we can also say it's an environmental benefit. But then the question of how you monetize it as a benefit might be different depending on whether you're approaching it as a societal benefit or as an environmental benefit. And these cost tests also kind of help set that framework for how you're going to begin to include or not include certain types of costs and benefits, and then from what perspective you're trying to give them a value.
Okay, so somebody wants to know, and this is following on your comments here. So the various tests show things from the viewpoints of three main entity actors: generators, consumers, and society, right? So that's the question. Are these tests looking at the same question from the viewpoints of different actors, or is it something else? Is there something else going on here?
That's basically it. Not from the utility cost test is from the perspective of utilities, the distributors, not from the generators. But yes, it's if the test didn't exist, then you could start the whole process over and say, okay, I am a ratepayer. What kinds of costs affect me? What kinds of benefits affect me? And construct a test on that. So these are sort of preset groups of costs and benefits that are typically included in a ratepayer impact test, in a utility cost test. The societal cost test is the one that actually has the most variation in how it is employed, that a lot of states put different bits and pieces into their societal tests than one another. But the concept of it is that it's meant to capture costs and benefits to society at large, and not just to ratepayers, not just to utilities.
Okay, and so that kind of points to the fact that, as you said, one person's benefit is another person's cost, right? So if you're installing lots of distributed clean energy resources and people are using more solar, and then they're installing batteries so they can even use more solar because they can save some of it and use it when the sun goes down, and so they're purchasing less grid power. You could see that as a benefit to the customer or the society. The utility might see it as a cost, right? Because it's costing them sales, right? They're not selling as much electricity because people are now relying on their own behind the meter generation. So that's just one example, but you could kind of look at it as somebody, as the attendee said, you know, the perspective of the test may determine whether something is a cost or a benefit.
Yeah, absolutely. I mean, with the specific example that you gave, Todd, in terms of utility finding that to be a cost, people getting more of their energy from their own solar, absolutely. But so the but is that in a lot of states there's something called decoupling, that, you know, when you brought in the example of energy efficiency a second ago. So that's kind of a system for protecting utilities from exactly that problem to some extent anyway. And then the other thing is that utilities may find it a cost to them to lose customers for energy, how much energy is being sold in the year, but they might find it a benefit even to them, even to the utility, if those reductions happen at the right time. And the right time to reduce, as you know, is at peak, when energy is exponentially more expensive to produce than it is at other times of the day and the year.
Right. And that's the value. That's a large part of right now what people are finding is the value of energy storage, because now we're not limited to just producing clean energy when the sun is shining or when the wind is blowing. We can now put it on the grid when it's needed the most, which is typically sort of end of the day when those peak demand hours are happening. We are going to have to wrap this up. I want to thank both of you and Applied Economics Clinic. I also want to thank everybody who's been in attendance. It's been a great webinar. Again, this is highlighting a new report jointly produced by Applied Economics Clinic and CESA, and it's available on our website and on AEC's website. It's called Energy Storage Benefit Cost Analysis, a framework for state energy programs. There's a lot more detail that we didn't get into today. So if you're interested in the topic, please go download the report, and I'll now turn this over to Samantha in case we have any upcoming webinars to announce.
Thank you.
Thanks, Todd. We will have webinars coming up. We've got a lot in the works, but we don't have any currently on our calendar, so stay tuned.
Okay, well, it's early in the year. We are always working on new webinars, and all of them get recorded and archived on the website. So for those of you wondering if you can get the slides or rewatch portions of the webinar that you might have missed, yes, you can. Go to our webinar archive. And we'll see you again next time. Thanks, everybody. Bye-bye.
Thank you so much.